Welcome to this presentation on Solid Principles, Part 1. Today we will be diving into the Single Responsibility Principle and the Open-Closed Principle. Let's get started. First, let's talk about what Solid is. Solid is a set of 5 design principles used in object-oriented programming. These principles help developers write clean, maintainable, and scalable software. By following Solid, developers can ensure that the software is flexible and easy to adopt over time. Here's a breakdown of the SOLID acronym. S stands for Single Responsibility Principle. O stands for Open Closed Principle. L stands for List Scope Substitution Principle. I stands for Interface Segregation Principle. T stands for Dependency Inversion Principle. In this session, we will cover the first two principles, Single Responsibility Principle and Open Closed Principle. Let's start with the Single Responsibility Principle or SRP. This principle states that a class should have only one reason to change. In simpler terms, each class should be responsible for only one job or functionality. Why is SRP important? By adhering to this principle, we can make our code more readable and easier to maintain. When a class has only one responsibility, it is easier to test, debug, and extend. SRP also encourages modular design and reduces the risk of bugs when changes are made. Let's look at an example where SRP is violated. Suppose we have a report generator class. This class is responsible for three things: generating a report, saving the report to a file, sending the report via email. In this case, the class has multiple responsibilities. If we need to change one of these, we risk affecting the others, making the code harder to maintain. To follow SRP, we can break the report generator class into three separate classes, each with a single responsibility. Report, responsible for generating the report. File manager, responsible for saving the report to a file. Email service, responsible for sending the report via email. By doing this, we ensure that each class is responsible for just one task, making the system more flexible and maintainable. Next, let's discuss the Open-Closed Principle or OCP. OCP states that a class should be open for extension but closed for modification. This means that we should be able to add new functionalities to a class without changing its existing code. Why is OCP important? By following OCP, we can extend the behavior of a class without modifying the existing code. This reduces the risk of introducing bugs in the existing functionality and makes the code base more stable and scalable. Let's look at an example where OCP is violated. Suppose we have a graphic editor class that handles drawing different shapes like circles and rectangles. Each time we add a new shape, we modify the graphic editor class. This makes the class difficult to extend and increases the chances of introducing bugs. To follow OCP, we can use inheritance and interfaces. We can create a shape interface with a method like draw and have each shape class like circle and rectangle implement this interface. The graphic editor class will then handle all shapes uniformly, and adding new shapes will not require modifying its code. To recap, the single responsibility principle ensures that a class has only one reason to change, which leads to more maintainable and testable code. The open-closed principle tells us that a class should be open for extension but closed for modification. allowing us to add new functionality without changing existing code. Both principles help in creating flexible and clean software. Let's put our learning to practice. For the first exercise, refactor the following order processor class to follow the single responsibility principle. Right now it handles multiple responsibilities. How do you separate them into individual classes? For the second exercise, refactor the zoo class to follow the open-closed principle. Right now the class checks for different animal types and modifies its behavior based on them. How can we change the design so that adding new elements won't require modifying the zoo class? To conclude, today we learned about the single responsibility principle and the open-closed principle. These principles are the foundation for writing clean, maintainable code. Next time we will be discussing the Liskop substitution principle and the interface segregation principle. We encourage you to explore these concepts further and think about how they apply to your own project.